All right, I have two more parts to this one. The first one is asking us what the patient's heart rate was after 2 hours. So this is asking us for an age, and it's giving us a T, which means we can't just use H of Q, we need H of Q of T. So in the long run, we want H of Q of 2. You can either do this by taking the 2 and plugging it back into function Q, and then taking whatever you get and plugging it into function H. You can also do this by building a formula for H of Q, and then when you're all done, you can plug in the 2. I'm going to do the second way, not because I think it's easier, I think it's a little messier here, but because I know that it'll be convenient to have that formula for the next part, the last part of this problem. So let's go ahead and build an H of Q of T, which means we're taking function Q of T, which is a 500 over T squared plus 2, and we're plugging it into H. H will take whatever we give it, and it will give us 60 plus 0.2 times our input. I think we can do a little bit of simplification here. A 0.2 is the same as a 1/5, so I get to cancel and say I have 60 plus 100 over T squared plus 2. All right, so the last part of this one is to go ahead and plug 2 into that. Now that we have a formula, we don't have to plug the 2 into Q and then into H. We just plug in right here. We say we have 60 plus 100 over 2 squared plus 2, which means we have 60 plus 100 over 6. I can type that in slowly, which is approximately 76.67. So this is saying that after 2 hours, the patient's heart rate is at 76.67 beats per minute. All right, so for part F, we want to know when the heart rate is below 70 beats per minute. So we have heart rate as a function of Q up here at the top, and we have heart rate as a function of T right down here. I would say in this problem it's slightly disguised again, but it says when. I think we want to relate heart rate back to time, so figure out the time interval at which their heart rate is below 70 beats per minute. So we can start by just setting up an equal to, and then we'll have to make some decisions about whether we want stuff to the left of what we find, to the right of what we find, that sort of idea. So we want this to be equal to 70. I am going to subtract 60 from both sides. I am then going to multiply both sides by a T squared plus 2. So I have 100 equals 10T squared plus 20. I can also subtract the 20, so I will get 80 equals 10T squared. I can divide by 10, which will give me 8 equals T squared, and then I can take the square root. Don't forget the plus or minus. So T is approximately 2.83, and I am going to make the decision to use only the plus there, so don't forget that you have to make a decision, but in this case we do end up only wanting the positive root. We don't want to look at before the patient got the injection. I don't expect these exact same equations to hold for before the injection. So now the question is her heart rate below 70 beats per minute before this time or after this time? Are there any other cutoffs that I have to worry about? So one thing we could do is look a little bit at this information. After 2 hours, their heart rate is above 76.67. We know that initially the heart rate was, did we do that? If t equals 0, we get 250. I don't think we did that, but we can do it really quick. So just to check a couple of these, we know that h of q of 2 is about 77. If we want to plug in a 0, we get h of 250. So I think that's going to give us 110. Let's double check my arithmetic. 60 plus 0.2 times, what were we were plugging in 250? Oh. Hold on, I can't type. I've got extra digits. Okay, 110, yeah. So it appears that before we hit the 2.3 hour mark, our heart rates were above 60. We could check the 3 hour mark. So we would have 500 over 3 squared plus 2, so 9 plus 2 is 11. 500 over 11 will give us about 45.5. If we then plug that in, we get 69.1. Okay, so I think we're on the right track. The other thing you can do here is you can go ahead and graph this function. Where did it go? This one right here. H of q of t equals that. You could graph that on your calculator and see if it's increasing or decreasing. We can probably even do a little bit of that by inspection. As t gets bigger, the denominator of this fraction gets really, really big. So this fraction is going to shrink, and that's going to give us our decrease. Okay, so after 2.83 hours, the patient's heart rate drops back down below 70 beats per minute. And the other thing this is telling us that you may or may not have spotted is that as this shrinks, we're getting closer and closer to 60. So 60, again, that was their initial heart rate, and it's also the heart rate that we taper off toward after they get the injection. All right, thanks for watching.